Benji, and today I'm going to talk about deepfake detection and creation and how linear algebra is actually one of the hidden tools behind it. Every day we scroll through TikTok, Instagram, YouTube and see videos of celebrity politicians and even normal people. But with deepfake technology, a computer can now create a totally fake video that looks almost perfectly real. So, the big question for my presentation is the one in the speech bubble. Can linear algebra help stop deepfakes? In the next slide, I'll first explain what the everyday problem is. Then I'll show how we can turn videos into matrices and vectors. And finally, how linear algebra can help us detect which videos are real and which are fake. In this presentation, I will show how linear algebra can solve a very modern problem: deepfake videos. Deepfake videos are AI-generated videos that make people appear to say or do things they never did. They are a serious issue for social media, news, and even politics. We will see how we can turn videos into numbers, use linear algebra to analyze them, and help detect which videos are fake. Today, almost everyone watches videos on TikTok, YouTube, Instagram, or X. But what if a video of a celebrity, a politician, or even a friend is completely fake, generated by AI? Deepfakes can spread fake news, destroy reputations, and be used in scams or bullying. So, the everyday problem is simple but powerful. How can we automatically check if a video is real or fake using mathematics? This is where linear algebra comes in. A video is just a sequence of images called frames. In linear algebra, we can represent each image as a matrix. Each pixel in the image becomes a number, for example, showing how bright or how colored that pixel is. All these pixels values from a grid of numbers, which is a matrix. We can then flatten this matrix into one long vector. So, a face in a video becomes a big vector of numbers that we can work with using linear algebra. Once each face frame is converted into a vector, we can think of it as a point in a high-dimensional space. If two videos show the same real person in a natural way, their face vectors will be similar, so the point will lie close together. If a video is a deepfake, some tiny pixel patterns will look different, so the point may fall in a different area of the space. Linear algebra gives us tools to measure similarity using distance or dot products, and analyze patterns using methods like PCA, which stands for Principal Component Analysis, or SVD. These tools help us separate normal faces from strange or manipulated ones.
Hello, my name is Bobo, and in my part I would like to talk about detection steps. So in detection step 1 and 3, now we can describe a simple method to detect deepfake using linear algebra. Step 1 is collecting frame. We first take the input video and insert frame where the face is clearly visible. Step 2 is to convert to vector. Each face frame became a matrix of pixels value, and we flatten that matrix into one long vector. And step 3 is building a training set. We collect many examples of real faces and many examples of fake faces. Each example is stored as a vector, so we can embed with a bit matrix where each row or column is one face example. This matrix is our training data for the detection system. And this is detection step 4 to 6. Face vector can be extremely long. We use linear algebra method like PCA to reduce the dimension. PCA finds the most important direction of variation and keep only the key feature. And step 5, we learn a boundary. In this smaller feature space, the real faces and fake faces tend to form different clusters or regions. We can then learn a simple decision boundary such as a line or a plane that separate real images to fake. Step 8 is Step 6 is clarify a new video. For a new video, we convert its face frame into feather, project them into the same feature space, and check which side of the boundary they fall on. If many frames land in the fake region, the system flags the video as a possible deepfake. Why linear algebra is suitable? Linear algebra is a very suitable tool for deepfake detection for several reasons. First, images and video are already matrices of numbers, so linear algebra is the natural language to describe them. Second, face data is highly dimensional. With thousands of Bessel values, linear algebra provides a framework to handle these high-dimensional factors, reduce dimension, and find meaningful direction in the data. That many of the operations we need, such as measuring similarity, projecting data, and transforming it, are directly expressed using matrix and feather. Finally, almost all the modern machine learning and deep learning models rely heavily on matrix multiplication and feather operation. So linear algebra is not just useful, it is essential. And challenges and future work. Even though linear algebra gives us a strong foundation, there are still several challenges. Deepfake technology is constantly improving, so the detector must keep learning from new examples. Attackers can also design videos that try to fool the detection model, which is also known as adversarial attack. There are also ethical and privacy questions about who controls these tools and how they are used. For future work, we can design better ways to extract features using linear algebra, combine this method with more advanced deep learning models, and build real-time detection systems for social media platforms. This shows that linear algebra will continue to play an important role in fighting deepfake in the future. So for the summary and closing, to summarize, we started with an everyday problem. Can we trust the video we see online, or are they deepfake? We saw how linear algebra helps us turn images and video into matrices and feather, and how we can use these feather to analyze patterns. We walked through a step-by-step detection pipeline, convert frame into feather, reduce dimension with PCA, separate real versus fake using a decision boundary. This shows that linear algebra is not an extra subject from dashboard. It's a powerful tool that helps protect truth and trust in digital world. Thank you for watching. And mathematics quickly protect what we see and believe online. This is our reference used in our presentation and video for the images and for the data.